Hello everyone, my name is Kachan Wutunjai. I'm a lecturer from Biological Engineering program, small department in Faculty of Engineering. You might not heard about our program before simply because we have only master and PhD course, not for the bachelor degree student. And then you might asking why I came from biological engineer and why I can handle the class that talking about introduction to computer programming. Okay, so I would like to introduce myself first. I'm a nerd, like simply a nerd. I love technology, I love playing games, I love computer in general, and then I study in bachelor degree in computer engineering at KMUTT. And then back in the day, I do the research on artificial intelligence. And at that particular moment in the research world, I still feel like, okay, AI is still stupid. Like it's extremely stupid. It's not this great in the same quality that we have nowadays. And back in that moment, somehow I think if I understand human brain more, then I can develop better AI somehow. So that's why I shift my study from computer engineer and extreme to biological engineer, and then in the end I'm studying cognitive neuroscience, which is something like combination between psychology and neuroscience. Okay, so I shift my field quite a lot, and nowadays I doing research mainly on how human making decision, basically to study human bias, why we have a bias, why we change our decision over time, in terms of the function related to information that we provide to you. Okay, so my working experience in the past mostly in the software engineering side. I'm working on database before, game development before, and also being the project consultant of software house in the past. So that's why from those kind of experiences, the faculty of engineer asking me to help operate this course for chemical engineering student. And hopefully we should have a chance to meet in person somehow. I mean, for sure, after the university open, we're gonna do the lab work, hands-on, and do some coding practice together in KMUTT. Okay, from now, I would like to mention like why human invent computer from the starting point. Basically, it's because we are lazy. Yo, we are extremely lazy. And that is a fact of humanity. We hate to keep doing the same thing all over again by ourselves. We hope and we wish that some days everything gonna operate by itself and we just laid back in sofa playing games and eating some snack. That is like Garfield. Okay. And that's why we invent computers. And basically we made it for doing math first. In the past, I mean, you guys might born with calculators all over the place, but when I'm a kid, we had to do all the hand calculation by ourselves. I mean, that is until my high school. In high school, we still not allowed to use calculators, and that is a painful job, you know, like all day, 24 hour math quiz, math question, math assignment. We had to do it by hand, drawing on paper, and we send like a big chunk of calculation to our teacher to get in score. And that's why, like back in the day, a lot of scientists wish they're gonna be some machine to do the calculus and extreme calculation for them. And that's why, and this is my face doing a math test. This is I like this meme a lot. Back in the day in calculus class, I'm kind of like remember most of the thing in the final exam, and that's why we need some kind of machine function or automatically program that gonna help us to do some extreme calculation. Okay, but we're gonna be the one who decide how the machine work, and then the machine gonna operate the routine work for us. Okay, so I mean, in movie you're gonna see this kind of images a lot. Programmer gonna be some like extreme person who have like extremely fast fingering and typing speed, and they can do the code for hacking the system or saving the world in just like 2 or 3 or 5 minutes. But it's not true. Okay, most of us gonna look like this. Okay, we look at our code, change something, and then somehow it's work, somehow it doesn't work. So in this class, I hope that I can help you understand why it's work. Okay, that is a big question that I would like to provide the basics and the understanding in programming until you guys have well enough of knowledge to judge that the code is work because of why, and why it doesn't work when you manipulate something in the code. Okay, so basically the computer programming is talking about the process of design and building. It's not about the coding itself. So when we're talking about programming, I would like to remind that is on the process of design, how program work, more than the coding itself. Okay, and it's work for what? It's work for finding some kind of solution for some specific question that you would like it to do. Okay, you made the program for doing calculus, you made program for create 3D object, you made the program for, I don't know, searching for active chemical compound in pharmaceutical industry, for example. Those are specific questions that you need to have beforehand. Then after that, you gonna decide how program gonna work out until it can find a solution for you, and that is programming. Okay, it's not the same thing with the coding. So I would like to mention the history of programming, like from the museum stuff. So back in the day, around like 19th century, they start making the mechanical computers made by a lot of clockworks, and then it's gonna help you to calculate the calculus. For this machine, they can do calculus. Okay, and this is schematic of how it's making layout and how the clock works and treats the number one by one according to the input of the calculation itself. And they use this kind of punch board. Okay, here as the code. So when the machine read the paper and found a hole, they will assign the one number digit to the calculation. But if it's found the unwhole papers space, they will call it as 0. This kind of calculation has been done before the electronic computers being invented. So you can see that people are really extremely lazy enough until they spend the whole lifetime to create this kind of machine for help them calculate the mathematics. Okay, another problems that being created is for design the for calculate the polynomial equation and also the logarithm scale. Okay, these two are extremely hard to do by hand in the past until they can invent mechanical equipment to help them for the calculation. I would like to mention that I love this movie a lot, The Imitation Game. It helps you guys to understand the context behind the very first electronic or modern days computers that being invented during World War II. So the guys who invented, which is acted by Benedict Cumberbatch, is Alan Turing. So this is his real face, and Alan Turing, he is like a father of all computer science. So he made the Turing machine that help us to manipulate symbol in the strip tape, and according to the strip tape, it can calculate or do some predefined algorithms. So it means this is the first machine that can reprogram. If you look at the clockwork before, it's created for one specific function. You cannot reprogram it to work for example, like that's one created for calculus. You cannot make it to calculate, I don't know, 3D object or load balancing or kinematic models for you. You cannot reinvent it like that. But for Turing machine is the very first one that you can identify the algorithms, which is the state or the kind of like schematic of how machine think. Change the way it thought to help you resolve the different kind of question. And the ACM Turing Award is kind of Nobel Prize for the computer scientists all over the world. And the name of the award is named after Alan Turing. Okay, so the most famous thing that he invented is called Turing test, which is the test that nowadays still used for testing the AI. And the test itself designed for testing or evaluating that AI is similar to human or not. Basically, by this kind of procedure, we can test that AI have intellectual intellectual level equally to human or not. Okay, you can read more detail from the link below. I think it's pretty interesting story that you can study it by yourself later on. Okay, back to modern day computers. So nowadays we can call it that computers be something like very, very affordable and in the range of the consumer prices. And the architecture behind that is going to have something that get the input and represent the output, which is, simply speaking, is going to be monitors, right? This one can be keyboard, mouse, etc., right? But then it should have storage, which is your hard drive or solid state drive, right? For the modern PC or even in your iPad or your tablet or your phone. Anyway, it still need to have main memory, which is mostly gonna call RAM. Okay, and the core processing unit still made for doing arithmetic and logic calculation. Okay, so everything behind all program in the world, every single application in the world, behind the scene is the logical operation or mathematical function behind that. Not more than that. Just only two things behind, okay? And this is like the real schematic. If you look how the IC and all the stuff wiring on the main board. This is the shape and the form of main board itself. I just put one as an example to giving you kind of like visualization of how schematic being changed into the real hardware itself. You doesn't need to remember this, but please keep it in mind that nowadays the port that used for input devices still used for output as well. For example, USB port, you can plug the pen, mouse, and everything, the keyboard, in USB port, right? But in the same time, it can be used for, connect via USB 3.0 to the monitors. So it can be used for two functions, either input and output. Then nowadays it have an acronym of I/O, which is input output port. Okay, and this is a place that you're gonna place your CPU on, and the place for RAM, and the socket for every single thing else. You don't need to remember this, but try to keep it in mind that computers have input input port, input hardware, output hardware, and the computational unit that compute only arithmetic and logic function. Okay. Then what is going to be the future trend in the future? If you're watching the news, they have a news that the NVIDIA companies acquire companies, which is for people outside of technological fields or computer science fields, it might be like some random news out there, but it's extremely big news because ARM itself is a new architecture that not the same with the computational unit that you have in your laptop, but it is used all over the place for smartphone and tablet. All over the world, they use the architecture of ARM processing unit, not the current CPU, which is x86 architecture. So what happens is, after NVIDIA acquire ARM, in the same time, Apple also, have another big announcement that they have new CPU called Apple M1, which is now have the product in MacBook Air, or MacBook Pro that use this chipset already. And this one also made under ARM architecture. What happened is the change of architecture might be happens in next 5 to 10 years, and it's gonna affect a lot on how the processing unit work, because ARM itself is not made like mainly for arithmetic and logical unit. I mean, it's still used for operate logic a lot and simple mathematics, but it's not have like vector calculation inside. It's still slow for something else, but it's pretty good at the hardware and responsive. As you can see that your iPad is very fast at swiping and also touching function. And this gonna be the big trend in the computer world in 5 to 10 years. And I would like to ask you to keep in mind that after the course, I will mention again how it's gonna affect the way of thought in the next 10 years. Okay, but how is affect consumer? How is affect student who study computer programming nowadays? I would say no, not at all. It's not affect you guys at all, because the programming languages still be the same. Programming languages. What it changed is it changed the hardware and architecture inside, and the companies will find the way out to help people or facilitate the process of programming, and don't let the programmer change the way they making input at all. So simply speaking, you still use the same code that you're gonna learn at this class until somehow we didn't code in electronic computer at all, maybe the quantum computers or maybe the DNA computings in the future. But ARM or x86 is not gonna bother you guys at all. So the knowledge that you're gonna gain from this class will be useful in the future for sure. Okay. So I would like to mention again that coding is not the same with programming. Coding is the skill. Okay. After the design, you need to have ability to code, to change your design to be the same languages that program or machine or your computers can understand. So the coding itself, as you can see here, simply speaking, is translator. It's the skill that you can translate the design that you made in human languages into machine languages. But programming itself is a bigger picture that you're talking about how to create and development the programs. Also how you're gonna debug, which is mean that how you're gonna find why program doesn't work or why program work, and also translate the requirement back into the documentation. Okay, so basically coding is like extremely niche skill, but programming itself is bigger picture, and it's not like mainly talking about the syntax and languages and the line of codes. And programming gonna be the main objective of the class itself. Okay, I would like to mention that even though in the end you are not good at coding, it doesn't mean that you're gonna have a bad grade or I don't know, like bad feedback from the class, because I also try to measuring your programming skill first. Your coding skill is like a top up for the class. Okay, this is the thing that I would like to ask you to expect from the class. You might not be the extreme good coder, you might not be able to code the iPhone games by yourself from this class, but you're gonna have the good programming logic. Okay, basically in this world they're gonna have like three processes that computer gonna work. You need to have input put into a process in your computer, and it's gonna show some output on the screen. However, input is gonna be it's off quite a bit. Let me see. Okay, wait a minute. Okay, input is gonna be anything that we decide that is gonna be put into the program. However, output itself is also created by your hypothesis, which is like you want to design this program to do this specific function. So you need to have some hypothesis in your mind that if you put this input in, what kind of output is gonna be. So your job is to create the process. Only the process of how to change input into the output. And that's all for the introduction. I want like to keep mentioning again that programming mainly work on the process only, because input and output is predefined. And starting from next episode, we're gonna talking about computational thinking or computational logic, which is mean the simple way of how to think as a machine, how to think like a machine. If we think like a machine first, then we will understand how the programming languages work, how it translates the logical state into the workable application. Okay, thank you for your time. If you have any comments on the setup or the way I teach or the way I create the online materials, please write out below in the Facebook group. Okay, I will try to like change the way I create this content following your suggestion if I can do it. Okay, thank you for today and see you around. Bye bye.